Okay, we are back with another case solve. This was today's round, and I performed terribly on this. I think I got something like 400 points, and then as always, right after the case, kind of figured out how to solve everything quite nicely within little time. So I'll share that solution now. So these questions are all independent, which is quite nice. You can tackle them in any order, and unusually the last one is worth a massive amount of points. So this is worth 420 points, which is a very difficult map case. It's a bit like the old Bear Island case, but on steroids basically. Because that's such a long question at the end, let's try and get through everything else quite quickly so we have time to finish that one. So the first question is asking us how many glasses of apple cider we can make, and it takes 4 apples to make 1 glass. So we want to divide the number of apples here by 4. So if we say length of that string divided by 4, we get 14.5. However, the example is 7. And the reason for that is if we pull one of these emojis out, the length of it is actually 2. So some emojis have length 2 instead of 1. So we need to actually divide by 8 instead, or divide by 2 again, either one works, and then round that number down. So let's do that, and that should be our answers. Now, there is something in the beta version of Excel, I don't know whether I have it on mine yet, but I know there's kind of a way, a drop-down box to choose either type 1 data or type 2 data. I think in a future Excel update it will work off type 2. And type 2 works properly with emojis, so if you were set to that, if you were on the beta channel and had access to that feature yet, you would just be able to do the first version of the formula. I'm going to just pause and see if I can find where it is. Okay, I can't find it, but I know I've seen that somewhere on a YouTube video. Now let's do the bonus. So the bonus is asking how many glasses can we make if we use all the apples. So we just want to concatenate all of those and then do the same formula. So that gives us 90. The next question, we have this dial here, and it's a lock. So we want to, if it's left, we're turning it anti-clockwise. If it's right, we're turning it clockwise. And we want to know what the code is, which is specified by this. So this dial is working in mod 10, the numbers 0 to 9, and it rotates and repeats. So what we want to do is, I have a lambda that extracts numbers. So first of all, let's do that. And then I want to extract the arrows. So to do that, I can say text split this on this array. That's going to give me the arrows. I want to get rid of those colons, so let's just substitute out the colons for nothing. It's actually semicolons. There we go. So what we want to do here is move from 0 26 times anti-clockwise and see what number we land on. So let's set that up. We're going to have mod. The number is going to be if we're moving left, so if this equals left, and let's hard code that, then -1, otherwise it's 1 times this number, and we are doing modulo 10, so actually it needs to go there. So we would move to 4, which is our first digit, so we should just be able to move that across, and this would be our code. However, on the second number, we're not starting from 0, we are starting from 4. So we need to plus on where we start from, which is the last number. So that gives us 452, which is our code. So this is all we need to do for this one. And then we can say concatenate these 3 numbers, and that is our answers. So for question 3 here, this is doing very high exponentiation, which will generate numbers which are too big for Excel to display all of the digits off. So it will cut the end digits off and display them as zeros, and give you it in like scientific notation. So in the real thing, I didn't do this question because I was like, this is hard, I can't remember how to do all this stuff from the simple case. And then afterwards had an epiphany of, oh, you just use Python and then it's really easy. So first of all, let's text split this on the caret operator and drag that down. And then in Python, all you need to do is type py, and I want to do 32 to the power of 26. And in Python, you use double asterisk to do to the power of. And if I do that, Excel won't display it properly, but I can tell Excel to display it as a string by wrapping that in string, or I can tell Python, sorry. And now I get the whole string. I can see the last 5 digits are 45824. So let's change these to make them these 2 numbers. The problem with this one is it won't work because I haven't told Python like what types of data these are. So I need to say that those are integers. So if I wrap them both in int, then it knows to do the maths on it and that they are numbers, first of all. So now we get the answer down there. Let's get rid of this thing. And then I can just take the right, this, comma, 5. That is actually the answers, but the reason they're displaying as incorrect is because this is formatted as text, because the right formats things as text, and it needs to be formatted as a number. So I just times it by 1, and that will give me the right answer. So let's just copy those in as values and delete this stuff out. I want this sheet to run quickly for the last question when we get there, so I'm just going to delete the workings out quickly. Let's also do the next bonus while we're at it. So what is the last 10 digits of 42 factorial? So factorial is basically 2 factorial is 1 times 2, 3 factorial is 1 times 2 times 3, and these numbers grow very quickly. So for this one, I just asked AI what are the last 10 digits of 42 factorial, and that is this long string here. So I can see the last 10 digits are this 40 million or whatever it is. So 4, and that's how I did that one. There's probably a way to do it in Python or maybe with Excel, I don't know, but yeah, I just asked AI for this one. So now back to some more normal Excel questions. So in question 4, there are 34 sentences here. So first of all, we want to rip those out. So let's text split this on full stop space, because that denotes the end of a sentence. And let's do it by like this. Now in the case, these actually have full stops on the end, so we want to add a full stop onto the end and full stop. And now we have the full stops back, so let's copy all of that as values. We'll notice the end one has 2 full stops on the end, so let's just remove that. And now we have a list of sentences. So all we need to do is X-match the sentence on this list, and that is it. It will tell us what number it appears. That also means we can do bonus 3, which is if you add up the sentence numbers that were not used, what would the total be? So for this we do the opposite. So first let's do sequence, I think there's 30 here, there's 34, okay, so 34. And next we want to go the other way. So we're going to say X match this sentence in the questions, and we need to include the example this time. I forgot to lock my cells in the live thing here, so I got this one wrong again. And then we just want to basically filter this list for where it's not there. So let's say filter this list for where is error this. And then we get our list of numbers that are not there, so we should just be able to sum those up. And that gives us 194. Okay, the next question basically gives us a list of things people like and things they don't like, which is going to match up to these categories. And we need to find the dislikes and likes and then figure out who it is. So basically from this text, we want to pull out these categories and then whether they like it or dislike it. One complication is that it doesn't always use the word likes and dislikes, like in the example. It sometimes uses these synonyms. So for likes, it might say admired, appreciated, enjoyed, favoured, and so on. My original idea when I did this was just to look for all the text after this second colon, because I thought these were always the disliked items, because I scanned down and could see that, oh, it's always that the dislikes come after. It turns out that's not true, so you do need to factor in these synonyms. However, you only need to do it for a couple of them. So first of all, let's find out whether dislikes or likes come first or last in the list. On inspection, we can see that we always have this and they text in the middle. So let's do text split this on and they. And I think this has to be case sensitive, so let's just make sure that is. So here we can see the first word is going to be whether it's a like or dislike. So let's just take the last column and then take the first word of that. So let's do text before the space. Then to find out whether this is a like or dislike, we need to use one of these synonyms list. So let's take the likes synonyms here, and let's also put on likes because that's one of the possible words. Let's text split it on the comma space, and then let's search for this in here. And let's just remove the others so you can see what that's doing. That's basically searching that second word in here. So if there's a number here, it means the second section is the likes. So let's say or is number. And for those that are true, is where likes come second, which is only these ones. So it's not many of them. So I would have got 4 of these wrong in the real case. So all I'm going to do for these 4, because there's not many, is I'm manually going to flip the dislikes to the likes. So let's copy that. So let's copy those over here. So they dislike wobble only, so let's get that on the end. 2 more to go. And then this one. Dislike those. Okay, and now we have like a good setup to do this. So let's just delete all this out because we don't actually need it anymore. And let's do it in a data table. So example 5. And then let's take text after the second colon, and that's going to give us all the things that they dislike. So let's text split that on comma. And now let's get our headers here, and let's say if exists, which is one of my lambdas, bear in this list, then give me dislikes, otherwise give me likes. And then we basically have our code which should match this. And then all we need to do is find where it's the same. Then I'm going to come over to this level 5 tab. I'm actually just going to say equals this for now. And then I'm going to say and this equals this. Oh, and let's lock that. And then there's going to be a true on who the person is, which is this person, Hannah, and that matches the example. So now let's do xlookup true in here and return the person. And let's do the whole thing with a data table. So this is basically what I did the first time. I just missed that this is basically what I did the first time. I just missed that the things weren't always in the same order. So yeah, not ideal, but I didn't lose too many points on that one. Okay, level 6, I didn't get to do this one in the real thing because I went down a stupid rabbit hole. I watched a video on something like this the other day. It was an Owen Price video where he has data that is like this. I think it's a depreciation schedule or it's an asset purchase schedule or something. And he uses pivot by to get it into a nice formula. And I watched it literally last night. So I tried to mess around with pivot by, you know, this and so on and so on. But to do that setup, you want some helper columns. So let's just quickly remove these blanks because they are quite annoying. So I'm just going to delete the blank rows. Now I need a flag for where each song starts. So I'm going to say exists song number in this. And that is going to give me a, oh, I need a space there, a true or false if it exists, okay? So I'm going to put a minus minus on that. So this allows me to see when each new song starts. So where that's the case, I want to say if that, then give me the cell below. Otherwise, give me what was above, which I can't do for this one. So let's do that for now. Drag that down, and if it's false, give me what is above. And what you'll see is that whenever the song changes, then song number 2 is listed with the right header, this is listed with the right header, and so on and so on. So all I now need to do is XLOOKUP the sentence in here and return the name of the song. And let's just delete out all of my stuff from earlier so that I can speed the spreadsheet up for level 7. Let's just do a bonus quickly before we move on. So on level 6, how many times does the word Harry and Harry's appear? So all I need to do is search for Harry, because Harry is contained within Harry's. So a couple ways to do this. First of all, let's just get rid of this because I don't need it anymore. One trick people use to search for things is to just Control F and find all of Harry. So if I find all, it will tell me the 103 cells found. However, if Harry appears twice in one cell, it won't count the second one, so that would give me a 1 instead of a 2. I want to count all instances of it, even if it appears in one line multiple times. So you could instead do the find and replace Harry with nothing and replace all, and there we get 106 replacements. So let's just Control Z that, so the answer is 106. Oops, if I type it correctly. Now the way I actually did this in the real thing was to concat all of this. Then I said text split this on space, and let's do it down, and then I did exists Harry in here, and I wrap that in a minus minus. And you'll see the sum of those is 106. So that's the way I did it in the real thing. Okay, and now on to the beast of a question that is level 7. So this has most of the points in the case at 420 points. Basically, we have a bunch of characters, but they can only move in certain directions. They need to go from a start cell, collect an item, and then go to an ending cell, and we need to determine how many steps that is. Now, this is a common map question, and the map is here, so let's just copy this out to a new tab and call it M. So the way we usually do it, and most of you will be familiar with this, is we choose a starting space, so say it's here, we label it as 0, and if we could move in any direction, we would want this 0 to be surrounded by 1s. That tells us the distance to that cell. So to do that, we can say equals the minimum of everything around the cell plus 1. And you have to have circular references turned on for this. So if I was to now paste this everywhere except there, we would see that from 0 the numbers kind of branch out, 1s, 2s, 3s, so on across the map. So to find the distance to any location, we just indirect that cell on the map and it gives us the distance. Now, there's a couple of tricky things on this. The first one is that we're starting somewhere doing a route, and then we're starting from that new position and doing a different route. So we need to do this process twice over. That's the first difficulty. The second difficulty is that the directions that people can move in are all different. However, you notice Howard here is a duck. He can move on water. However, the other animals, wherever they are, cannot move on water. So we also need to account for that. But if you were to just do the easy version, which is Howard, if I just do most of this, you'll see that Howard appears 7 times in this list out of 20. So if you just did the easiest version, you'd have got most of the points on this level. But we will do a general solution for all of them. I'm going to take this same idea. Whenever you have obstacles, in this case water, and you need to avoid them, you generally want to do this circular references approach. So what I want to do, instead of just taking the min of everything around it, I want to take left, right, up, down, and all the diagonals individually, and determine how long it takes to get to those places. So if I take Lana as an example here, if she needs to go down, what can she do? Well, she'll have to go down and diagonal, down and the other diagonal, and then up, and that will get her to the equivalent of 1 square down. So for her to move 1 square down is a distance of 3. So what I would want to do is do this circular method, but for anything down, it's going to be the minimum of the one above plus 3, and then the minimum of however long it takes to go from the right or the left, and so on and so on. So that's the way I'm going to build it in. That might not make much sense now, but hopefully it makes sense when I do it. Now the first thing I'm going to do is whenever you do these map cases, the edges are really annoying because you can't just do the same formula for all the cells because the edges, whoops, don't have anything around them to iterate from. So I'm actually going to just insert here, and I'm going to do the same on this map. And then I'm going to shift all of these down and right, all of these references. So let's take my arrows, lambda, and I just want the down right one, which is here. And I'm going to use my lambda to say move on map from this cell with this arrow. That's going to be the new cell. And I'm going to do the same for this one. And then let's just replace those so we have the new starting locations and the ending locations. And the reason that I've done that is, like I said, I can then copy the same formula over on my map without worrying about these edges. It's probably a small time save rather than changing those formulas. Another thing to note here is the first check I did is I wanted to see how many of these objects appear in the map, because the question asks that they go to the closest one of these objects. So if there's multiple of them, that complicates things, and you'd have to kind of flatten the map, which I'm actually going to do now because that's something we need to do. So I have a lambda flatten this, and it's going to tell me, I should have probably done it a different way, start at the bottom and go like this. So that's the map flattened. Let's just copy his values because this is going to be very processing intensive. I want it to run as fast as possible. This is what's in the cell, this is the cell it's in. Let's just do a count if the map is this item. And what you'll notice is there's only ever one of the thing we need to go to on the map. So these are basically fixed cell references we can go to. So instead of objects, we might as well change these to cell references. So let's do equals xlookup this item on our map, our flattened map, to give us the address. Let's actually pull that up one. And then again, I'm just going to copy this into here to make it easy. Now we have all of our set up. Let's do it. Example 7. So start cell is going to be this, end cell is going to be this, and then we need to do the calculation again, but I'll copy the tab and have my start cell as this and my end cell as this in another tab. So first of all, let's sort out this water business, Howard. So I am going to actually delete this because I don't actually need the original map anymore. It's a bit dangerous to do that, but whatever. And let's do Control H, let's get the water, and I want to replace it with W for water. Okay. Now I want to say if address of cell A1, whoops, we're on B2 now because we moved the map, equals the start, give me a 0, otherwise give me a blank. So this is our first formula. So we'll see a 0 appears in our starting cell. So we're going to say if the cell equals W, and we want to combine that with if it's not Howard. So let's say and. So it's water and this equals Howard, let's do, if it's not equal Howard, do blank, otherwise give me the address of the cell. Is that right? Give me blank, otherwise if address of the cells is that, give me 0, otherwise give me blank. Let's just put something else there for now, so you can see what this is doing. So this is, so I basically want to change these x's to distance calculations. Let's just show you what it looks like with Howard. So Howard appears in question 102. So if I change this to 102, you'll see Howard can be on the water as well. So next up I want to do those distance calculations. So to do that, I want to pull in this table here. I only actually want these. And I want to list out how long it takes to get to any direction. So this will make more sense in a second. If I just transpose that and give it the same headers, let's just zoom in a bit here. So I basically want to figure out how long it takes someone to go down a cell, each person to go down a cell, each person to go up a cell, each person to go right a cell. So if I look at Lana here, she can't go down. So to go down, she needs to go down diagonally right, down diagonally left, and then back up again. So it's going to take 3 steps, a distance of 3, to go down a cell. So this should be a 3. Now I don't want to go through and do this manually because it would take a while. So what I can first of all do is say, I can use my exists lambda again, exists this arrow in here. And let's wrap that in minus minus. So this is at least going to give me the distance where they're all ones. So let's copy that as values and just quickly delete out the zeros. Okay, so we need to fill in all the other, so we need to determine all these other distance calculations. So I'm actually going to do this manually because it's fairly quick. So Hannah can only move up, down, left, right. So to go diagonally, she'll go, up, right, up, left. It's going to take 2 steps. For the others, they all have 3 arrows. So I'm just going to figure it out manually by thinking about it. So I'll explain a couple of them for the thought process, and then I'll speed up the video and fill them all in. So like I said, for Lana to go down, she's going to go down diagonally both times, then up. So it's going to be 3 steps. To go right, she's going to go down diagonally and up. So it's going to be 2 steps. To go left, she's going to go down diagonally and left and up. So it's going to be 2 steps. Up right, up, down left, up. So it's going to be 3 steps. And then up right is going to be down, right, and up 2. So it's also going to be 3 steps. So I just need to do that for 3 more characters. So let me do that, and then I will be back with you. Okay, so we have our table filled in of how long it takes to travel in each direction. So let's just do, zoom out a bit, and let's do equals xlookup, whoever it is in here, and return the distances. And let's just put these arrows on here. So now I want to add into my distance calculation from there. So again, let's just put this as blanks quickly, and do that. So to go from the cell below, it's going to be the minimum of whatever is above, plus how long it takes to go down. And let's lock that. So to go from here to here is going to be 3. Now the problem is if I put that above, because there's nothing above, I'm getting an error there. So I am just going to box this in with 1000 quickly. And I basically want to figure out the calculation for these cells here. So to go from above, it's going to be minimum of that, or coming from below plus how long it takes to go above, and we lock that. So to go up, it's 1, to go down, it's 3. So let's now add this logic into all of the cells. So I'm actually going to copy this formula here, and I'm just, let's copy the top one in there for a second. So I always basically want to do the minimum of, if I do the cell to the right, I want plus the distance from the left. There we go. So we should see that this grid works out. So to go up, it's a distance of 1. To go down, it's a distance of 3. To go right is a distance of 2. Left is 2. Here is 1. Upright is 3. Down right is 1. And here is 3. Okay, so I now want to expand this across the whole map. However, I need to have these bounds in that are higher than any number, because otherwise this part of my formula will take the minimum of the cell outside the map as 0, and it will just take this value instead. So let's quickly wrap the borders of the map in 1000. And here. And then let's copy this formula across the whole map, and we should have all of our distance calculations, which we don't. Okay, and I think this is because the water is taking the minimum. This is not working because the water is trying to take the minimum of the water, which is 0, and add the value. So I need to actually change this water to 1000 instead of a blank, so that this is always bigger as well. So if I do that, then I think we should be working. There we go, and we have all of our distances around the map. So all we now need to do is do indirect of this. So that's our distance to the object. All we need to do now is repeat this. So let's copy it to a new tab, and in this tab our starting location, so actually our example, let's just link it to here, it's going to be this. Our starting location is going to now be AL10, where the banana was, and our ending location is going to be the ending location in the question. There we go. And now our final answer should be this distance plus this distance, which is 80, and that matches the example. So now the final step is to data table this, which is going to be huge. So let's wait for that to complete. Because this takes such a long time, well, it only takes like a minute or so, or 30 seconds, it's still time wasted. I should probably rebuild some of my lambdas to not use indirects. I should probably build some kind of move path lambda that's not circular reference based to speed this up, because it's been a problem in a number of cases now where I've taken this approach thinking it'll be fine, and as the cases get more complicated, it gets slower and slower. Okay, so this should be our answers. And it is. Okay, for the final bonus, I've set this up so we have the model. We're going to go from BA73. The question asks from AZ72, but because I've shifted everything down and 1, I need to bump the row and the column up 1, so that would be BA73. And we're going to go to AE, so it's going to become AF52. So AF52, the banana was in AL10. This time we want to calculate for all of these people, and this is going to equal this. And let's do it. So we want to go equals this plus this. We can actually drop Lana off here to do it a bit quicker, because Lana is my example data table. And let's change that. Let that whir around, and then that will be the bonus done, hopefully. Okay, and the sum is 881. 881. Okay, I make the answer to be 881. The case makes the answer to be 909. I can't see anything wrong with what I've done. I've just paused the video and checked it. You know, I've got this set up correctly, so it drives from the other tab. And yeah, I'm calculating from the right places. I make it 881. I'll put a comment in the future if it turns out that it is 881 or whether I made a mistake, but I think it's 881. Okay, I've just figured out what's wrong with my bonus. I actually need to change my circular references to iterate more than 100 times. So let's allow iteration up to 200 times and see if that fixes it. So let's refresh here. I think that's the issue, because I'm iterating 100 times and something needs to iterate more than 100 times to get the right answer. That is very sneaky, and I never would have thought that. Obviously, when you turn circular references on for these cases, you normally do it up to 100 times and you always get the right answer, so that's completely unexpected. So the answer should be 909. So now I get 909. So yeah, the answer is 909. Wow, that was a really hard case. It's crazy to think how we've gone from Bear Island being hard to this. I mean, Bear Island's a 10-minute case now, but back in the day, people struggled with it as much as they do this one now. So that's the levels we're at. Yeah, good case, really fun.